Hey, how's it going?
It's going great.
Awesome. So we're live. We're going to talk data engineering today. And so we got the Seattle data guy. Ben, you want to give a quick intro?
Yeah. Hello, everyone. My name is Ben Rogojan. Again, Seattle Data Guy. You can pretty much find me across most social platforms underneath that moniker. So basically, I do end-to-end data science, data engineering consulting for companies kind of range in sizes from, again, kind of small to mid and large, focusing a lot, again, on developing core data platforms and solutions. So helping companies kind of figure out what tools they'll need, whether they're kind of looking more for like a Looker or Tableau, what they need from a data warehousing perspective, what pipelines they should be using, and different components across that whole kind of landscape. And I've been doing this for a while also kind of working originally in healthcare as well as healthcare analytics at a startup, eventually into big tech, and then at this point doing a lot of consulting and content creation. So I think at this point, I've just kind of run the gambit.
That's awesome. Cool. And I'm Joe with one half of, I guess now one third of Ternary Data. So we're a data engineering firm in Salt Lake City. And
yeah, Matt Housley, I'm the other half. So Joe and I we're just kind of getting more into the content game. So we're very excited to see people like you been making this work and kind of following in your footsteps. But yeah, we've been doing consulting in the data engineering space for a couple of years now. And so for us, we mostly focus on the engineering part and a little bit less on the science, kind of hand that off to other people.
Yeah.
That's awesome. Cool. But anyway, I think we wanted to talk about data engineering, and we got obviously it's a live Q&A. So anybody in the audience who wants to, ask a question, feel free to do so. Happy to answer those. But we have some questions we want to start out. It's a common thing I think that comes up in a lot of our content is people looking to get into data engineering or switching paths to get into data engineering. Do we have any career tips for people who are interested in data engineering?
Yeah, I mean, as far as career tips go, originally when I started like out of college, I think like most of us, we don't even know that data engineering is a thing. I think data engineering is starting to become a little more popular. I don't know if it'll ever get the same traction as data science, but it is starting to become at least a little more known. So I didn't really know about it. I was doing like BI work. So I think I started learning about like Tableau, originally started learning like about SSIS, SSRS. So for anyone who doesn't know, that's like Microsoft's like old stack for kind of data engineering work and reporting development. And so that's like where I originally started to learn. I like started just on YouTube tutorials on those tools. I think the big thing I tell people is don't learn tools, learn like principles and best practices. So there's like a Udemy course on like, I don't remember what it's called. But it's basically like basics to data warehousing and ETLs. And that's like where you need to start, I'd say. Because I learned like about SSIS originally, and I had no idea that it was like, there was like a term like ETL. I just learned that you could move data with SSIS. And I didn't know that there was actually like a whole process and like good practices around it. So like when I first started, I just would build on it, and then eventually learn more about ETLs, kind of the reason we do it, how we do it, testing, and different points like that. So I'd say really focus on like finding a good baseline, so you actually understand. Also, then you're going to be able to pass interviews much easier because someone's going to ask you, design a data warehouse using like Kimball style, and you're going to be like, who is Kimball, right? Like it's like, what is that? So understanding that is really important. So that's kind of the baseline. What other kind of career tips? The other thing I usually tell people is like don't get stuck up on being either a data scientist or a data engineer. Like, look, if what you can get is an analyst position from a data perspective, but it's letting you touch a database, start there. That's where I kind of started, more the BI analyst route, and then pivoted more into data engineering because I'd done a lot of development and learned programming in college. It's just sometimes you just don't get that job that you want. So I just say, especially if it's your first job, don't get too stuck up on it, and try to pivot, either in the company or, as you're at that company, learn the skills and interview somewhere else. And that's usually what I'd say.
That's awesome advice. That's really good. I like the fact that you mentioned like don't focus so much on tools, right?
Yeah.
I don't think we hear enough of that. I mean, it seems like every blog post is about like, how do I do something with Spark, or how do I do X with BigQuery? And those are super useful, but yeah, to your point, they're not the right way to build your career trajectory. In some sense, you want to focus on a lot of tools, like kind of dabbling in a few things.
Yeah.
And then when you actually get into building a project, then you're going to get really good at Spark or BigQuery or SQL Server, whatever the tool happens to be at the time.
Yeah.
Yeah.
Yeah, I would agree with that. I think, some people become very good at a specific tool later on. Like, I think that makes sense. I think like, eventually in your career, if you want to become like, I am an Azure, consultant, that's what I do. I know people like that, but I feel like they've been in the industry for a while. And, one, it's very profitable to be like very focused like that, kind of like it used to be very profitable to be like, and it probably still is, to be like an Oracle consultant, right? Like it's a very profitable niche. But I feel like that takes like, you probably want 5-10 years of experience and you want to have done kind of a little bit of everything. And now you just decided to focus. But yeah, especially at the beginning, it's just like, there's so many different tool sets. It's really hard to say like, oh, I'm going to learn Fivetran and become a Fivetran consultant, or I'm going to learn, whatever, Snowflake or BigQuery. I think I like what you said, like dabble in lots of things and know where they fit, know what they kind of do well from a high level. And then once you have to do a project, then really drill into it and, learn all the details, because otherwise, again, there's just too much for you to learn everything.
Yeah, I completely agree. In fact, a lot of the data engineering journey is more about choosing the right tools. And that's very, very hard because there are so many voices telling you to use different tools. Use Spark, use Airflow, use BigQuery, use Apache Beam, like whatever it happens to be. And so you really have to develop the skills to like have data intuition and then kind of evaluate the tool by talking to a lot of people and then deciding what's the best fit for your use case. I've seen way too many teams. Spark is a great framework, but a lot of people just jump to it as a default, like Spark equals data engineering, which is not at all true.
Yeah. Yeah, and I think it's also driven a lot by the use case, right? Like it's like, okay, you're doing like more batch ETLs because you only need this report once a month. Well, okay, use Airflow, right? Like or something that's more batch ETL-y. Oh, you need this live. Okay, now we can look at streaming. Like it's about considering what you're actually doing and not just like, again, like you said, we like this tool, let's use it. It's like, well, Spark, in my mind, requires a lot more technical expertise, and thus you're gonna have to find people that understand it, which is gonna be harder to maintain than if you use maybe something else like that's very easy for people to maintain. So it's about like, again, assessing your team, assessing the actual thing you're trying to do, and there's a lot of different components in that. Not just jumping to a tool without thinking about what does that actually mean down the line for me. What's the technical debt I'm taking on by picking this tool? What's the maintenance that's gonna be taken on by picking this tool, and all those other kind of steps along the way.
And even things like the time to delivery for a project. So for example, if I take on Spark, it's inherently a more powerful framework than SQL. Yeah. It's also, every project is going to be more work because a lot of things that are super simple in SQL are hard in Spark, just fundamentally.
Yeah, I totally agree.
Is Joe saying something? Oh yeah, I am the strong and silent type. Let me just post a question here. It's from Alec Dutcher. What's up, Alec? How does somebody with no background in coding, either academically or professionally, learn how to write production-ready code? Any resources or best practices you would recommend?
And I have a question for Alec right off the bat. Does he know any SQL? Let's start there.
Oh.
When I hear no background in code, a lot of people say SQL isn't code, which is completely false in my opinion.
Yeah.
Right, but let's assume maybe we're talking about one of your usual suspects, right? So sure. Java, C, Python, etc. So
I think my big point here would be like, first you're going to need to learn the baseline of code either way, right? Like it doesn't, like learning production code should not be step one. Learning coding basics probably should be step one. Whatever, loops, functions. Depending on where you want to go, object-oriented programming, maybe a little bit about data structures and algorithms. Not like as a data engineer, it's not a huge thing that we need to know, but I think it's always nice to know, at least from a high level. And then from there, it is really hard, I think, to replicate production-ready code, like an environment like that. Like that was a struggle I first faced, I think, my first job. I was the only technical person on the team. Like I got hired, they were supposed to have like kind of a more experienced person that was going to work with me. That person was there for 2 weeks and then left over for Amazon. So it was just me. And like, I definitely built out a lot of not production ready code, but I was like, this looks good. Like it's working, right? Like it's great. Like, and so it wasn't until like the next job that I went to where I like learned more about like the production process, like how to get code out there, QA, things like that. So it's really hard to like replicate that environment if you're not having to work with other people, work through a process, understand kind of why you're doing it. Cause it's like, if you're just coding by yourself, like you don't need a process, right? Like if you're a one dev team, like the part of that whole reason that I feel like for their process is like, because there's multiple people involved, I guess. So it's hard. Personally, I feel like it's hard to replicate, but I will also let someone else, ping in on that.
I would say like, to write production ready code can mean a lot of things.
Sure.
But I think there are some standards though on software engineering teams, right? So I would say like, even if you're working in isolation, there are some, I would say there's some good books and good people to follow.
Sure.
Rob Martin's Clean Code. It's a classic book. Pragmatic Programmer, classic book. The people at ThoughtWorks write some like phenomenal articles. Neil Ford, Martin Fowler, so forth, have fantastic articles on software architecture and best practices. I would say like lean on the stand on the shoulders of giants and learn what good code looks like. I would also say, so I did a lot of Django development several years ago, and the way I think that improved my coding style, because I would, in order to understand some of the nuances of that framework, I would dig into the GitHub repo and like at an atomic level, start looking at how they structured their code. And I would say Django's got one of the best code bases of any software framework out there. And I'm not the only one that says that. There's a lot of people that say that. And so look at what good code looks like from maybe a project that is highly vetted by very good developers and software engineers. I would say that provides you a good template for what production ready code looks like. Now, of course, that's one aspect of it, but then it depends also if you start working on a team, depending on what the code review style is like, or what the expectations are for, what production ready is, code notwithstanding. We're talking then about CI/CD processes and just deployment processes, right? Then like production ready means a lot more than just what your code semantically would look like. It also matters like how does it execute in an environment? And so there's, I think, a lot of factors at play that might not be totally obvious, right? And so, and it also depends on the systems you're running. So if you're running a distributed system, you're probably not going to be running stateful code for a lot of reasons. So whereas if you're working in a place where that's not really a problem, then just sort of it depends. But again, I guess maybe the advice, if I were to boil it down, is like kind of understand where you maybe you want to work and the types of tools you want to use, and then understand what production ready code would mean for those. And by that, I would say look at the GitHub repository code base and just understand like what does good code look like in this context, and then how would it look like if it's deployed. So I'm sure let others chime in.
Yeah. And a couple of things that resonate here. So Ben, what you were saying about getting on a team, I think that's a fantastic idea. Like most of us just need some context, like a framework to learn these skills in. You can definitely learn a lot on your own, but you need to be, ideally you're on a team that has DevOps and you're building in an automated fashion and maybe even deploying in an automated fashion. And so you can learn about all those processes. I think it's really good to have mentors too, people who are like reviewing your code. And so I've taught people Python a couple of times and as part of my jobs. And one of the things I found again and again, going back to the comment about algorithms, is that they would understand, okay, here's how a dictionary works and here's how a list works, but they wouldn't understand the efficiencies. So if you try to like search through a list for something, it's very, very inefficient. Whereas dictionary, I can just do a quick lookup. And so I would always like, even if it were a short list, I'd make them rewrite it if they'd done it the wrong way, just so they would learn. And then I hope they're doing that for other people as well. But yeah, mentorship just has a huge impact on your practical learning of how to write quality, clean code that will pass code reviews and just follows good general best practices. And then I'll loop back to my question about SQL earlier. And the reason I asked that is that I think SQL is a very good starting point if you intend to end up in data. Because if you work on SQL a lot, you're learning the data way of programming and how to think about things in parallel and how to think about set theory. You build that foundation really solid, and then probably next you go into Python, which is a great way to learn basic programming, then eventually object-oriented programming from there.
Yeah, I think just as like the one funny thing I will say, because Joe, you brought this up, like look through other people's code base. That's like honestly what like eventually told me all the previous code I'd written was terrible. I was like looking through someone else's code and I was like, I understand everything I'm looking at, and it's not like it's commented, but it's not that commented. This is what it's supposed to look like. It's so intuitive.
It's sort of like when you start a sport, for example, right? And you start becoming decent at it. And then you start thinking, oh yeah, I'm like really good. And then you see a professional do it for the first time. You're like, I ain't
nowhere near.
Nowhere even close. Yeah. So, but that's, I come from a sports background, and I've always felt the best thing I could do. And I think this alludes back to the team, is just surround yourself with people who are the best examples of what you want to become.
Yeah.
And it might be humbling. It might suck actually, for your ego, but that's the way you're going to learn to. Of course, you got to find those people, right? And that's where, if you can't find them, then there's definitely good resources out there, books, like endless articles and videos. Videos are great these days. I mean, geez, there's no shortage of great information on YouTube, and I mean, right now
a lot of great programs out there. Yeah.
So many good ones. Let's see, got another question. Thanks, Alec, for the question there. Let's see, any tips? Exclamation mark. From Ketan Sahu, I think. Sorry if I mispronounced your name. But your question is, what should I build to tell recruiters that I have knowledge and passion about data engineering? Already built a stream and batch data pipeline in AWS. And currently working on designing a warehouse.
It's funny because like this is like currently the next, or at least one of the many videos I would like to work on next, which is like, data engineering projects, because I feel like data engineering projects are often sometimes harder to talk about because it's like very, at one level, if you're just doing the data warehouse, it's like very intangible, right? Like it's like, oh, I built a data warehouse, but that's really hard to explain. So I'm trying to think about like, what are things that are very tangible? So like probably one thing you could do is like maybe do build like a website, like scrape some information off of like some government website, build some sort of dashboard or something on top of that and put it out on a web app or something. I think that could be at least some sort of application that's very tangible that you can talk through. It forces you to think kind of end to end, right? Like you have to think a lot more than just, I pulled this data. It's like, okay, but how did you deliver it? And all these other kind of portions that kind of get dropped sometimes. So I think that would be an interesting project to kind of add on to your whole thing. And then again, you can share a link really easily, and then people can see it and maybe think about it.
Yeah, I like that. Yeah, we actually riffed on this last week during the Monday morning data chat, data engineering portfolios, and it's an interesting one because you're right, Ben. The work it's not like a data science project where you could just have a notebook where you could run make a model or make a matplotlib visualization. Yeah. It's the exact opposite. I kind of joked with Matt. It's kind of like if I made an oil refinery or something, right? And it's kind of let me just send you a sample of it, like that. Really,
would you like some gasoline, like 85 octane?
Yeah, or do you want the pipes from it or something? Like I don't know how that's going to work. So I think to add on to what you're saying, we kind of thought like maybe because data engineering is largely invisible, making videos and blog posts is another way too. Maybe you say that you made streaming and batch pipelines in AWS. That's cool. Make a video about it and talk about how it works and how you did it and all those kind of things. Because again, it's not like you're going to be able to send a recruiter your unless you send them like a CloudFormation template or something. But even then, it's kind of a lot of work to spin up. So show, don't tell. What do you think, Matt?
Yeah, I tend to agree, and I'm going to go back to what you said earlier, Ben, about not focusing on tools. And I'll say, like, focus on a variety of tools. In other words, in your portfolio, at least show that you kind of know something about what orchestration is, for example. So maybe you spin up a simple Airflow project or try one of the newer alternatives like Prefect or Dagster. And it's not that you have to be an expert in that framework, but you want a potential hiring manager to know, oh, this person understands why orchestration is important and how that fits into a data environment. and then they can onboard you and know that you're going to figure out whatever particular tool they're using to do that part of the pipeline. But yeah, in the cloud, you can try a lot of different things, and you don't want to go too fast, because it shouldn't be like, okay, I do a quick start, I don't understand anything, because that happens all the time. But like, do enough to start to understand the paradigms of that system, and then probably move on to something else, unless you're really, really focused on a specific job like Spark engineer or something like this.
Yeah. Yeah, I think what's also like, because you brought up content creation, I think that's kind of a great way to go. Like, honestly, for most engineers, just because, one, personally, again, I've put out at this point, I think upwards of like 200 articles, and it's
That's
cool
awesome.
going back. One, it's just cool going back and being like, wow, like that's all the work that I've done, and written over 100,000 word kind of thing. But also too, it's like you said, it's a great place to kind of show, and people can kind of see like, hey, yeah, this person cares about this topic, or they're interested, they at least know it from some level. And if you end up getting some traction, you never know, some recruiters might reach out to you suddenly. They might be like, oh, well, this guy is worth reaching out to. So never know.
Yeah, I mean, let me see here. Yeah, the question was like, how do I tell recruiters that I have knowledge and passion, right? So, yeah. I mean, what you said, Ben, I think is spot on. Where, I mean, you put in the effort and wrote a lot of articles at this point. I mean, that to me, that shows you have knowledge, because you're writing an article. I mean, to write something indicates you have knowledge of something. But then you also have a passion, because I mean, after a certain number of articles, I mean, you'd have to be totally mad unless you were very passionate about this kind of stuff. Yeah. And I would think you'd all want to have knowledge, right? Because you're publicly showing off your knowledge, right? This isn't like you writing in your diary or something. So yeah.
And I feel like the more important thing is that you're showing you know how to learn, right? Which I, as a hiring manager, that's my number one concern. I can take someone who's maybe a Java dev or who's just done SQL, but if I know that they know how to learn and I can train them to do what I want, then I'm going to be excited about that candidate.
Yeah.
Cool. Thanks, Ketan. LinkedIn user, I think it's Shubash, you can see over on LinkedIn Live, asks, I'm a senior software engineer and earning a nano degree. I'm assuming this is probably from Udacity.
Yeah.
In data engineering. I'd like to see myself as a data engineer. Any suggestions you could provide me? So I guess the context of this is you're a senior software engineer, got a nano degree, and you would like to become a data engineer. So I'll leave that to you guys to talk about.
Sure. I guess I can start. Yeah, I mean, I think the one like probably major component that I assume someone that's done software engineering, especially like maybe purely software engineering, is one, the knowledge of data warehouses and ETLs or ELTs, whichever one you're using, as well as maybe like SQL. I think SQL sometimes is a hit or miss with software engineers. Sometimes they know it, but purely from like a CRUD perspective, like insert, delete, update, but they might not know it more from like an analytical or data pipeline perspective. So that's probably one thing you probably want to make sure and then the other thing is just get a baseline in data warehousing and ETLs. Other than that, I would imagine that switch is very easy. It's probably easier than I assume like a software engineer to maybe like a data scientist, because it's like you already know the program, which is a big portion of it, and then you just need to understand kind of how you're applying that programming, which is slightly different than software engineering. I think that's always the interesting thing, is sometimes I can tell when a software engineer wrote a pipeline versus a data engineer, because it's just a very different mentality of how we treat code.
I suppose something else I look for is what I call data intuition. And I think a lot of your good analysts have data intuition, and I definitely want to see it in a data engineer. And that is, can I hand them, a big table and ask them to start digging through that data and understanding the schema and kind of understand how the data is bad and how to make it good, if that makes sense. So I'll give you an example. If anyone on the listening has dealt with GA4 data, so Google Analytics 4. So Google started sharing this data through BigQuery. You could just access it. And it turns out the schema is a huge mess. Like, trying to build reports that look like the console reports straight from BigQuery is really hard. That would be a really good problem to work on. And if you showed me that you drilled into that data and solved those problems, I would be excited to bring you on as a junior data engineer afterward.
Oh, sorry, some multitasking. Trying to respond to other threads here. For people who, by the way, if you want to ask a question, there's a LinkedIn Live thread and YouTube. So either one.
Nice.
Hey, what's up, Mark Williams? He's an old friend of mine. Awesome. It's good to see you, man. So I'm looking at the Udacity course here. Let me just see if I can share my.
Yeah, I wonder, can you put that up? And be interesting to look at it.
Yeah. So here's the program details, modeling, warehouses, data lakes, data pipelines, and a capstone. 5 months. Get a mentor. That's pretty cool.
Yeah. I think it kind of covers the core of it.
Yeah. So yeah, it's so I think it's an interesting question, right? What was the where was that? And you want to get into data engineering, I suppose. I think you guys get some really good tips. Actually, I don't know what else to add to that except maybe I don't know. What do you guys think about the notion of like picking an area of specialization early on?
It's always a hard problem, right? Because if you specialize too early, then you end up cutting yourself out of a lot of potential jobs. On the other hand, you make yourself a lot more attractive to a hiring manager if you've spent 500 hours or 1,000 hours working on Spark and they're looking for a Spark developer.
I guess it's hard to know where you would start though, right?
Yeah.
So yeah, that's the danger because you don't want to be like the person who starts out doing Hadoop or something right today.
Yeah, especially with Hadoop now, I feel like it's so abstract. Like in many cases, like, oh, well, it's there, but you're rarely interacting with it at the same level. I feel like often, at least that would be the smart thing for most companies to do. It's like don't force people to work with Hadoop at the Hadoop level. Hopefully, get some sort of abstraction layer on top. It'll be cheaper for you and more effective and faster.
Yeah. Don't write pig code.
No.
Yeah.
Yeah. I mean, and that is like the struggle, I feel like, in the tech field in general, right? Like we're constantly having to I think one of the topics you brought up was like data lakes, right? And it's like now that the term data lakehouse is getting thrown around, it's like, wait, data lakes came out like what, half a decade ago or something, like where people really started talking about it, and now we're like talking about a whole, not a completely different paradigm, but kind of a different paradigm. And it's like, what? I find it funny that data warehouses are still kind of sticking around in some regard, but like data lakes are like, maybe we try this a different way.
What do you think about, overall, what do you think about the trajectory of data lakes? I feel like it kind of turned into a failed experiment, except at a handful of companies. And it's not that data lakes have no value, but I think for most companies that deployed them, they just turned into a data black hole. What's the term one of my friends used yesterday? It was like, write once, read never. In practice is what most data lakes were.
Yeah, and I think that's kind of the issue. It's like it was so easy to treat it more like just a dumping ground of data rather than like some sort of structured thing. Which again, I get it. Like it makes sense. It's like we might need this. Let's save it. And it's this like, but why did you save it? Like I think this is why data engineers will kind of remain relevant even as like automated connectors become very popular and all these different kind of tools that are meant to make our jobs easier, which I love. But it's like, but at the same time, there's still like this level of like data governance and like, planning of data that I think still exists and will never, I think, go away. I think I've seen some tools that are trying to do pre-built data models. So that'll be interesting. Like, if everyone's using Salesforce or some similar tools, can you somehow just pre-built a lot of those models underneath things? Maybe. But I'm curious to see kind of just because there's so much more that data engineers do more than just like move data from point A to point B. Yeah, so.
And I feel like that stuff is growing in importance again, actually, not going away, but everyone assumed you can just throw it in the data lake. Don't worry about the schema. Don't worry about the structure. And now everyone's like, wait, if I want to do something with this later, I need documentation. I need schemas. I need all this metadata that's going to help a future data scientist actually make sense of this.
Yeah, it's almost like it's the way I think about like phone photography, like how like everyone's like, oh, well, with phone photography, like photographers are going to go away, right? Like, why would you? If anything, it's like, no, it just pointed out how bad we all are at photography and how much we're willing to pay for a good photographer to take pictures. So it's like the same thing with data. It's like, oh, we'll just dump it there. Anyone can access it. Anyone can use it. It's like, no, if anything, it's just pointing out the fact that we really need to make sure we know what's in there because we can't get value out of it if we're not like pre-planning and cleaning and making it usable for other people.
Well, I would say the trend of the lake house is interesting. It's another kind of vendor-driven buzzword, but I think we'll start seeing more of that. Databricks is going to be pushing the charge pretty heavily because they're IPOing soon, and then you got companies like Upsolver that, I mean, that's like literally all they do is just, Lakehouse, but even simpler. You don't need to do Spark. So, so this, it's going to be interesting to see how this plays out, because I think there is a place where people will maybe want to keep the data, sort of an object store and a data lake, and keep it away from you can definitely choose to ingest it into a proprietary solution, but at the same time, you might want to keep your options open. So I think you're going to start seeing more of that. But we'll find out. Let me see here. So hopefully that answers the question. And what's the next one here? Alberto. What's up, Alberto? He asks, since data engineering tools is so vast, in your experience, what are tools, languages, and frameworks to focus on?
I mean, I think at the end of the day, right? Like, you currently, at least for the near future, Python's not going anywhere, and SQL. Like, I think those are like the two. Like, I did like a video, like the data engineering pyramid hierarchy of needs, and I think at the bottom I put like SQL and Python, or I put coding, but like essentially Python, because it's like learn those first, and then like everything else will build on top of that. And then frameworks, I mean, you can learn Airflow, I guess. Like I think that's like, if you want to talk about the most common, right? Airflow is probably the most common in a lot of companies, or what most companies should switch to, because I think plenty of companies are still using patchwork. Like, yeah, it's like run on cron and
or control M,
Python
like,
scripts.
yeah.
And you're just like, you're $1 billion company, and this is how you're running this. This is hard. And it's hard. Like, it's just not scalable. But anyway, so those are the places I would start. Does someone want to build, like, what do you think is the next layer on top of that?
Let me take a step back, because we were writing about this for a book actually this week. The languages, I think, if I were to pick the primary languages of data engineering right now, Python, SQL, potentially a JVM based language. Sure, if you're dealing with any of the Apache frameworks, especially, like, you're going to have to know them, to at least optimize them. And then I would say bash scripting.
Yeah,
be the fourth.
Yeah, for sure.
Because without those four, and I would say it's more of like a 3.5, 4 question or answer, you're going to be kind of stuck. And then from there, I think I could possibly make some room for R, though it's not a data engineering language. You're going to come across it depending on the data team you're working with.
Yeah.
Other languages I keep on the radar is Rust and Go. Those two, especially Rust, I see that popping up everywhere.
Interesting.
To the point, I mean, even something like Materialize, I mean, I think it's written in Rust now, and I think people are finally starting to realize, like, there's a lot of good languages out there, and maybe Julia would be another one I'd maybe keep on the radar. But all these are like the things that you would look at, either because you have to, because you're working on a team, or you've mastered the 4 languages I mentioned, and you're like extremely bored and you want to pick up a new language. So, like, I was recently, teaching myself Swift not too long ago, mainly because I was interested in AR, but that's totally irrelevant to this conversation. But you know what I'm saying. But once you get those 4 down, kind of take your pick on what you want to do next. And then let me just put the question back up here again. Sorry, y'all. There's actually a lot of comments in here. Frameworks. What are your thoughts on frameworks?
I would say learn a cloud at least. I think at this point, a lot of cloud responsibilities land on data engineers. They have to manage a lot of their own frameworks and systems running in the cloud. And so consider getting like one of the data engineering oriented certifications. Each cloud kind of has its own flavor, but if you get the GCP professional data engineer cert, it's going to teach you a lot about cloud paradigms and a lot about general data engineering paradigms too.
Yeah, I definitely agree. I think you bring up a good point where it's like, don't worry about which one you pick. At the end of the day, AWS has AWS Kinesis, Azure has its own form of streaming. Like, everything has something. BigQuery, Redshift, like, yes, they might be different underneath the hood a little bit. There might be some different design paradigms, but overall it's like, but when you think about a solution, it's probably going to fit about the same. You're going to have to figure out the details one way or the other. So yeah, it's more about understanding the cloud. Like you said, there's a lot, like you said, like data engineers somehow also get stuck a lot with like setting up permissions, like maybe even setting up their own kind of virtual private cloud and all this other extra work that might might make more sense in DevOps, but we kind of have to, I think, often take on ourselves, especially again as consultants. When you go as a consultant, it's like, well, you're going to set up your own project from kind of start to finish. So yeah.
And we often lead the charge in cloud. That's what I find. Like data engineering is often the first thing to go in the cloud. Sorry, Joe.
Yeah, well, so I think to answer Roberto's question too, because I think that, you guys introduced a bit of a nuance to the frameworks topic, right? Because I think there's the notion of a framework like Spark, or Airflow, or Dexter, the other like million or bajillion other frameworks out there at this point. But then you mentioned the cloud, and I think for the purpose of this discussion, we're talking about the cloud. People doing data engineering in the cloud is, I think, predominantly at least what we encounter. We do have some on-prem clients, I think, between all of us. But frameworks, though, I would take a step back from the framework discussion and really understand how things fit into the data engineering lifecycle as well. So things like ingestion, storage, data processing. And then what are downstream users going to do with the data, as well as like upstream, like where's the data coming from that you're going to have to consume, and what types of databases are you consuming from, and what's the format and stuff? Because I think then that gives you a better rubric for understanding what frameworks to focus on. I think we hit on this earlier, right? There's this equivocation nonsense where it's like, oh, Spark is data engineering. And that's like absolute rubbish in my opinion. Like it's not the same thing. So take a step back and understand the fundamentals. And I think at that point you can better assess what frameworks are going to make sense. And obviously understand if you're doing data engineering for profession, understand what your client or your employer is using, because it wouldn't make any sense for you to learn technology or framework A if everyone's using framework B at your company.
Yep, I think it's a good point.
Yeah. Let's see here. Guido Zamora, he asks, recently I have seen machine learning engineer role being more mentioned. What is the difference between it and a data engineer?
I think if I were to look at the big difference, I think a lot of the times it's what we're implementing. Although a lot of people will implement like a machine learning model into something like Airflow, like if it's more of like a batch ML kind of process versus like, something live, which kind of comes across a little data engineering. I think that's like the main thing. It's like, what are we implementing, an ETL versus kind of an ML model. And honestly, I've seen like data engineers have to like implement ML models. And I've done like some like data science implementation, like where I was like handed a model from more of like a statistician and had to implement it. So, I'd say that's, also I think ML engineers, at least in my experience, have been more like the traditional software engineers, because they might also have to be dealing with a lot more optimizations and a lot more like fine tuning, other than SQL. But that's just in my experience.
Here's a nuance to the question too. Data versus ML versus AI engineer.
Oh gosh.
So.
Not sure what to say about AI engineer. To be
I was like, okay.
It's funny. I got the impression that the term artificial intelligence was starting to sunset, and it seems to have resurged in like the last year or two.
What are your thoughts on the original question, Matt? Difference between ML and data?
The first question. So I think, it is really, there's a lot of overlap between the two, because frequently machine learning engineers do have to handle their featureization and their data pipelines. But it's really a big difference in emphasis. Traditionally, whatever that means, because the whole field is very new, but traditionally, data engineers are going to be more focused on the data pipelines, maybe occasionally doing stuff on the data science ML side, whereas machine learning engineers are much more focused on the model building. And then if they're doing ops and hardware, it's more like TensorFlow and GPUs and those kinds of things that are specific to deep learning.
Yeah. I might add a bit to that, though. I think that there's increasingly going to be, there's a few threads to this. I think data engineers, they would take the data basically from maybe source systems to making it, basically taking raw ingredients and making them useful for data scientists, data analysts. From there, data scientists and data analysts may use the data however they want. And including machine learning practitioners, i.e. model builders in the data science part. Somebody who's going to maybe train a model, but then deploying it and setting up the production pipelines for what happens after or during the model deployment and after the model's deployed, that falls into the hands of a machine learning engineer. And so the machine learning engineering pipeline, I would say, is almost this parallel universe to data engineering. They, I think with few exceptions, for anybody with the luxury of having machine learning engineers, I don't see that they'll cross too much unless your machine learning pipeline, is a lot shorter, I guess. I can't really think of too many use cases where that is, because at the stage you need to hire a machine learning engineer, I would say your pipeline's mature enough where you would you'd have a separate workflow. Like the other night at our data engineering meetup, we had a talk about feature stores.
Yeah.
Right. Like that was. I don't. Maybe data engineers will work on feature stores, and maybe they won't. But I don't see them really. I don't see that becoming part of the vernacular anytime soon. Yeah. But here's where I say that there's a different thread, though, right? Because what I think is going to happen is all these divisions of labor, I think, are going to become a lot more intertwined. Where between software engineering, data engineering, machine learning engineering. I think over the next 5-10 years, the distinction between all these fields may in fact be very blurred for a variety of reasons. And a lot of it is because I think we're just going to find better ways of doing machine learning that maybe aren't obvious right now. In much the same way that software engineering has accelerated as a field, I would say software engineering is about at least a decade ahead of where data is right now.
Yeah.
In terms of best practices, and even that field's rapidly changing now. So.
Yeah, and then add on the fact that like ML is like 10 years behind data in itself. Like it's like ML ops, I feel like just became very popularized in the last few years. But that's because we've had enough time to develop those best practices to where we can start operationalizing it more. So there's still a lot of learning there, I think. And like you brought up feature store, and that whole concept is like both old and new at the same time. Like making it more of like a solution, I think is the new part, like where people are actually trying to sell it versus before it was like something you had to manage internally. So
yeah. And I was talking to somebody yesterday, and they brought up a really good point about data as a product, really, and that should be a way to think about things. And I think that I thought about it a lot this morning, and it resonated a lot, really, where if you focus on the product as an outcome, and then you start thinking in terms of like supply chain and kind of like an assembly line. It makes some pretty interesting thought experiments about where where data engineering and machine learning begin and end, I suppose, in terms of the engineering aspects of it and software as well. So
yeah.
Cool. I got another question. Let me see here. Sorry. Speaking of lake houses, how do you decide between a high capacity data warehouse like Redshift and a data lake like Spark? Looks to me like there's a whole spectrum of overlap between these solutions.
I guess if we're just like abstracting like specific tooling, like just data lakehouse versus data warehouse, I like to think that the data warehouse tends to be more of like this curated data set, right? Like it's very like, again, you've kind of gone through this concept of like maybe some sort of data governance and decided what data should be there, what data shouldn't. You've gone through certain like levels of QA, you've gone through certain levels of data modeling, whereas data lakehouses, at least traditionally, I feel like we talked about earlier, has kind of been, let's dump this data over here. Obviously, if you were to treat it better, you would think, okay, how would we structure it in such a way that someone in the future could actually use it and not just dump it in there? But even there, you're still kind of probably putting it in there, but in a very like specific way, right? Like you're storing it for future use. So, but you might not have like cleaned it up perfectly or QA'd it maybe perfectly, or parsed it out, right? Like you've got some data that's semi-structured or unstructured completely, like call logs or something like that, or maybe some IoT data or some like machine telemetry data where it's like you're going to need to parse it in the future. Whereas again, data warehousing, you've done all that parsing, right? Because I often like, or at least personally, it's like one reason, like data lakehouse is like, maybe you want to figure out if that data, or data lakes, maybe you want to figure out if that data is useful in the future. You don't know right now, you don't have time. We'll store it, we'll save it again in a way that's useful in the future. And then in the future, you might have a data scientist, a machine learning engineer, try to develop some sort of POC on that data. And if it's useful, then you might have a data engineer process it into the data warehouse if it needs to be faster for some reason. If it can still work off that system, maybe that's fine. But if there's some usage in the future, that's kind of one way I kind of delineate the two.
Yeah, and I guess from my perspective, usually you choose Spark because you need the language somehow. So in other words, you need some capabilities that go beyond SQL for your
Yeah.
particular use case. So you need to like dig into analyzing raw text, for example, and then Spark is going to start to be a lot more attractive. In terms of, I mean, you can use SQL with a data lake in practice. You can spin up something like Presto, for example. If it turns out that your data lake is really just a lot of structured data, then that does become an option. What are your thoughts, Joe?
I think these are all great points, and I don't have much to add in terms of what you guys have already talked about. I would say that there's also the philosophical approach, right? And so some people favor open source 100% of the time, right? And so if that's your preference, then probably Spark's something you're just going to be going with. That's how it is. Because at least you have portability with your code. Versus I would say, there still is concern if I use Redshift and I want to use Redshift, now I got to get myself off this, and that ain't fun. I've had to help people with that a few times, and it's a lot of work. So, I'm not saying I mean, switching platforms is never easy anyway, but some people I think just like the open source vibe, and so they just want to stick with it. But I think these are all good considerations. There's, and I would say too, from a cost perspective too, I think it, those types of considerations can make an argument for either one. Now, if I would say flipping it around and saying, okay, so if you needed to center on like, a SQL specific dialect, probably data warehouse is about as easy as you're going to get. But I mean, Spark offers a lot of stuff out of the box too. That's pretty cool. I mean, you can do graphing in it and like graph databases with like SparkX, I think, and like machine learning and a bunch of cool stuff. And I think Spark 3 supports GPUs. So I mean, you got kind of a whole pretty nice setup in there. But again, it just depends on what you're into. I don't know if there's a right or wrong answer. Right. I would say though, the anti-pattern I see when people are using Spark is they simply use it for a SQL for SQL queries. At which point I'm kind of like, well, I mean, maybe like BigQuery or Redshift would be better.
Or Presto, if you want open source.
Yeah, and so again, like whatever you're into, it doesn't really offend me either way what you use. So
yeah. I think that's kind of where, especially as a consultant, I feel like that's how we end up coming in a lot of situations. Like, I mean, what do you use? Fine, that's fine. Like, it's not gonna, like, if we have green pastures, it's great. But if you decide to use Spark, fine, we'll figure it out.
yeah, exactly. As long as you're not using like SQLite or something, I think
that could be a little challenging.
My first project ever was moving. It was only 10 gigs, but it was moving their 10 gig kind of like mini data warehouse off of Access onto SQL Server. So that, it didn't even fit in Access. They were running it off of like CSVs with Access on top of the CSVs.
Oh.
It was very, very funny. I was just like, this is wow.
I feel like data engineers have to be careful about making miracle promises with technology. Like, I think BigQuery and Snowflake are awesome technology. At the same time, they're not going to solve all your problems. But you do run into these horrible situations where it's like, okay, you guys have gotten yourselves into a total nightmare. I actually do think this tech will solve a lot of your problems, but we have to do a lot of work to get there.
Yeah.
Mm-hmm.
And hey, if you know what, a lot of your problems, if they can't be solved by the tech, they can be solved with money. It's like, oh, you need it to be faster? Do you want to pay more?
Maybe that's true of consulting as well. Just pay us money and we'll solve these problems for you.
We can be faster. We just need to hire more people.
Yeah.
And,
Yeah, that's an interesting one. It's I say the question that too, the answer to a data warehouse or Spark largely depends on the team dynamics, right? So, but yeah, I don't know. Like I said, it's take your pick. There's no shortage of tools out there, and I think that's part of the problem. And we talked about sort of the responsibility of a data engineer helping choose the right products. I think that with the ever-growing number of products too, a data engineer should be able to, I think, sift through and understand like the different nuances of the never-ending slew of options out there right now. So if it's not Spark and Redshift this year, it'll be something else and a bajillion other options next year. So which is about what's happening right now.
Yeah.
So
yeah. I mean, I like to say, like, I think Snowflake definitely helped that along once people realized, wait, this like data warehousing company is like the biggest like software IPO in ever. Oh, okay. Maybe we'll make Fivetran a $1 billion company. Maybe we'll start supporting these other tools, because it's like, yeah, if we can get stuck into people's systems, we can make billions of dollars. So it's very funny that way.
yeah, fish where the fish are, as they say. So. Cool. Let's see here. I think we got time for one more question. Another one from Guido. Is it wise to try and enter the data world in any position you can, like data analyst or I'm assuming, or scientist, and from that point to start making a career towards data engineering, or is it better to just focus on data engineering from the beginning? Actually, this is a popular question. Take a stab at it.
Yeah. Again, that's kind of the route I took, like kind of more from BI analyst to data engineer. I think it works, like, because you can often find the ability to do data engineering projects as a data analyst, because data engineers are often so overwhelmed anyways. Depending on the company you work at, some companies are very like strict, obviously, about like letting you take it on, but like if you try, maybe they'll let you. And once you've taken on a few of those projects, you can add that to your resume, and then talk about that in your next interview with someone. And then I think now that the position of junior data engineer is becoming a little more popular. I feel like I didn't see that as often when I came out of college. It was all like data engineer has to have like 3 to 5 years of experience, because they were really looking for people who knew what they were doing. But I feel like the term junior data engineer has come out a little more, because we just need more data engineers. It's like I think I saw like, and I think I've seen this article referenced by every YouTuber that does data, but like Interview Query. I don't know if you guys read that article where they kind of broke down. They interviewed or surveyed like 10,000 different people that did job searching last year, and a big proportion of it was all like data engineering. A very small, like data science was actually kind of waning, and things like that, where it's like data engineering has always kind of made up the bulk of data work. It's just data science gets all the fun streamers. So yeah, I mean, I think it's definitely not a bad move, but also if you can find a junior data engineering position, that's also great.
Yeah, I tend to agree. I mean, certainly if you know where you want to go and you can get that job, if you're able to get that job just right out the gates, then go for it. The thing that the analyst job gives you access to is data and data problems. And so you can certainly hack on data on your own. There's a lot of public data out there, but it's nice to have business problems that someone assigns you to solve within an analytics role. The other thing I might do is try to talk to people at your target company and find out about the culture. And so find out if it's a culture where people can grow from one job to another. And if they have a habit of promoting people or allowing people to move laterally as they develop their skills, then this is a really great way to get into data engineering. And yeah, data engineers are extremely hard to find. So I think most companies, if you get in as an analyst and then show data engineering aptitude, they're going to be happy to train you into that job.
Yeah, I would also, there's an opposite direction. I wouldn't say opposite, but another direction that isn't discussed, which is coming from being a software engineer.
Yeah.
Now, I don't know Guido's background, but I would say coming from a software engineering background into data engineering actually gives you a very strong base to do data engineering. I kind of equate it to like, if you're going to go into MMA, like being a wrestler might be one of the better skills you could have. And wrestling is, it's kind of like, that's, I think, what software engineering is. Because you can grind out any problem. And
maybe not wrestling to boxing though.
No, you don't want to be like a Ben Askren or something.
Thank you for getting my reference.
And so with software engineering, though, I think you learn a lot of good principles, and right now, especially with data and data ops, and sort of the worlds of software engineering and data merging. I think also coming at it from the opposite approach, where you've been exposed to all these principles already, like DevOps. Like this is kind of table stakes these days, and like knowing how the stuff works, being able to translate that into data concepts, I think gives you a very, very big advantage. Because I think it's, I've had the luxury of working in kind of all 3 areas, I suppose, in my career, like like data science analyst, software engineering, and data engineering, and so kind of seeing different aspects of it. And I would definitely say like, having software engineering chops is I think it's very valuable. So having data skills, though, I think gives you the empathy and I think the other side of it too.
Yeah.
But so if you're going to start with one, though, I think I think they're all valid answers. And increasingly, I would say back in the day, and maybe even 5 years ago, and definitely in the early 2010s, like I would overwhelmingly say that you would probably need to come into it from like more of a software background, because it was just harder. So
it was just harder, and I think like I don't know when Analyst made the switch from not knowing SQL to like having to know SQL, but like I feel like that's been more recent. Like I started with like when I worked with friends from Amazon versus when I was working with people that I worked at the hospital. Like Amazon, like they had to know SQL if they were an analyst. The hospital, they were using Excel. And so once you kind of made that switch and started having to use SQL, I think that's what's kind of made it easier for people to go from data analyst to like data engineer.
Yeah, well, and there was a time I remember in the early 2010s to like maybe slightly past the mid, like 2015 or so, 2016. SQL is actually written off for dead. Like if you were a data scientist doing SQL, if you're a data scientist using SQL, like you may as well just be wearing a mullet or something. Like that wasn't cool.
Are mullets back in too?
Well, yeah, they're way back in. And then if you were a big data engineer using SQL, like it was almost the same thing. Like, get that stuff out of here. We'd write Scala because we're cool. And then data scientists would say, oh, well, I write pandas. Like I don't touch SQL. Like that stuff's for losers. And now it's completely changed. Like SQL's back, ain't going anywhere. It follows, I can't remember the law. It's out on the tip of my tongue, but there was, there's this phenomenon in technology where basically it's called the Lindy effect, right? So the longer something has been around, the longer it's probably going to be around. So like SQL, Bash, things like that, right? So there's a certain longevity. And others, this person here mentioned Clojure might be another great for computing. I mean, I think that there's maybe some grain to that, but people I've seen using Clojure, I think they're kind of moving from it. So, not to disclosure the Clojure community, but I'm saying, it's either in technology, I think the cycles is such that you either get on the positive side of the Lindy effect and like you're there forever, even though there might be some bumps, some marketing hype that says SQL's out or something, or COBOL means COBOL will never go away. Damn right. That's awesome. Yeah, he's so right on that one. But others, I mean, how many languages come out? There's a lot, right? How many frameworks come out?
Oh, tons. Yeah.
None of us know. I was talking to somebody the other day who wrote a very popular orchestration framework, and it's like he mentioned there's like 200 orchestration frameworks out there right now. Yeah, it's crazy. So, anyway, we're coming up on time. Any closing thoughts on data engineering for today's chat?
I don't know if I have anything to close it. No, I thanks everyone for asking great questions. Hopefully people learned a lot. I really enjoy talking with everyone and answering questions.
Ben, so for people who want to find out more about you, how would they do that?
If you do want to find out more about me, you can my name's pretty unique, so Ben Rogojan, or just look up Seattle Data Guy. I YouTube, LinkedIn, pretty much everywhere, minus like Instagram. But yeah, you can find me there and find some more content on data engineering. Always interested in creating new content. So if you got questions about data engineering, send them to me and I'll try to make a video or an article and answer your questions.
Where did you get your logo? I love the logo.
My sister drew it up for me
so
like
cool.
3 years ago. I was like, she's like, you need a logo. I was like, all right, fine.
It looks like a skate t-shirt or something like this, to be honest. It's got a really awesome vibe. Like it says, I can help you if you're an enterprise, but I'm cool. I'm like,
exactly. Right. Like I'm a nerd, but also I'm a cool nerd. So
he'll show up to your office in a blue shirt and khakis and a mohawk.
That's right. Some face tattoos.
Awesome. And of course, Matt and I can be found at Ternary Data.
And the Monday morning data chat. That's probably our main channel. And we just turned it into a podcast, right? Like that was last week.
Yeah. We're on Anchor and all the other places where fine podcasts can be found. So check it out. And yeah, we're thinking about doing a show like this often on Fridays on LinkedIn Live and YouTube. So stay tuned for more information on that. Anyway, thanks to the audience for attending, and have a great weekend, and we'll see you next time.
All right. See you guys.
Take care.
Bye.